This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. We will try to derive the relationship between kinetic energy with the linear momentum. So if E is the kinetic energy, then E is equal to half mv square, and we know that the momentum will be given by m into v. If a particle is moving with a velocity v, then its energy is equal to half mv square and momentum is equal to mv. So if I put the value of mv in this, then we get the energy in terms of momentum and velocity, and energy will be half p divided by v into v square, and it is equal to half p into v. So it's a simple multiplication, it's not a cross multiplication. So the, and if I put the value is equal to p by m here, then we get energy is equal to p square by 2m. Anyway, we just say that E is equal to half mv square and v is equal to p by m. So 1 by 2 m into p by m square, and the value comes equal to p square by 2m. So energy is equal to p square by 2m, or energy is equal to half p into v. So this is the two formula which link energy with the momentum. So E is equal to half mv square is equal to half pv is equal to p square by 2m. And how the momentum will be linked with energy, then as we learned that p square by 2m is equal to E, so p square is equal to twice me, and p is equal to square root of 2me. So momentum is equal to square root of 2me. So this is the relation between kinetic energy and momentum. Now we learn various graphs of kinetic energy, and first graph is E versus V graph, that is energy versus velocity graph. So consider this is the positive direction, and if a object is moving in this direction with velocity is equal to 2 meter per second, and then we write the velocity is with a plus sign, that is 2 meter per second. And if an object is moving in the opposite direction with speed 2 meter per second, then we write velocity is equal to minus 2 meter per second. So as we know that kinetic energy k is equal to half mv square, so for m is equal to constant, for constant mass energy is directly proportional to v square. So whether the body is moving in the positive direction or in the negative direction, the energy will remain constant, as it is the square of velocity. So basically the path will be, the graph will be a parabolic graph. That is, for suppose the velocity is equal to 2 or minus 2, the energy will be equal to 4 for mass equal to 1 kilogram. So clearly this graph will be parabolic path. For m, for constant m, the energy versus velocity graph will be a parabolic graph, will be of type x square is equal to 4ay. So here x is equal to v, so the form will be v square is equal to, in the form 4ae, where 4a is equal to 2 by m. So this is our standard equation of parabola, and it is like that only. So now we will see the second graph, which is the energy versus momentum graph. So what is this energy versus momentum graph? So here also we consider mass to be constant. So if we consider mass to be constant, then as we know that energy E is equal to p square divided by 2m. So for m is equal to constant, E is directly proportional to p square. So the energy versus momentum graph is again a parabola having equation of the type, a standard equation of the type x square is equal to 4ay. So what these two equations signify. So the first equation, the first graph signifies that for a constant mass, higher the velocity, higher will be the kinetic energy, and it is quite clear from this figure also. And as per the second graph, that if you see the second graph, then what it means, that for a constant mass, higher the momentum, higher will be the energy. Now we will see our third graph, and the third graph is energy versus mass graph for constant momentum. So here, as we know that for energy, E is equal to P square by 2m. So if P is constant, then E is inversely proportional to mass m. That is, it means for the constant momentum, the lighter body have a higher kinetic energy. For a constant momentum, the lighter body has a higher kinetic energy, and this graph is called as rectangular hyperbola graph. So where this graph is of this form, or it is called, this shape is called as rectangular hyperbola. So if for constant momentum, if we reduce the mass, then the energy will exceed too much. And similarly, if we increase the mass to a very large value, then for constant momentum, energy will be less. Now we will see our fourth graph, and this is the energy versus momentum versus energy graph, and when the mass will be constant. So as we know that P is equal to square root 2 me, that is P is directly proportional to square root of E for constant m, for m is equal to constant. So again, if I draw the square root E as a y-axis and P as a x-axis, then clearly it's a straight line passing through origin, as the straight line passing through origin will be given by y is equal to mx form, and this equation is of the form y is equal to mx if we plot square root E on the y-axis and P on the x-axis.